Okay, number 15. Finally, get to use our calculator here. Find the intercepts. Y equals 7x cubed minus 8x minus 4. So the first thing that I'm going to do, and I'd strongly suggest on your paper always doing this, is sketching a graph. We're going to get something that looks like this. Yours might look a little bit more U-y. Okay, and then from here, I see two intercepts. Don't forget the x and the y intercepts. To get this y-intercept, we basically just need to plug in 0 for the x. So 0 equals 7 times 0 cubed minus 8 times 0 minus 4. That gives us y equals negative 4. So our one intercept is going to be 0, negative 4. To get our x-intercept, we are going to do the 0 feature of our calculator. So if you do the 0 feature of your calculator on this one, you should get it touching at 1.263. And remember, you do want to go out to 3 places. So if you don't remember how to actually plug that in your calculator, then you can go ahead and go to that video again and figure that out. And so when you do that, you'll get 1.2630. So those would be my two intercepts. Don't forget that we need the x and the y intercepts. Number 16. You will notice that this one looks very familiar. Whoops, I accidentally put it in 2 places, but I guess the practice will do us good. In order for a company to break even in manufacture and sale of a certain item, the revenue R for selling X items must equal the cost C of producing X items. If C equals 5.5 square root of X plus 10,000 and R equals 3.29X, find the number of items that must be produced and sold for the company to break even. So we want to find the number of items, which I notice is the X. So that's what we want to actually find on that one. All right, so we basically would like to set the two equations equal to each other. So we're going to be looking for the point of intersection. So I would suggest graphing this on your calculator. I do remember from this before, we let our X min be 0. We let our X max be 10,000. We let our Y min be 0. And we let our Y max be 15,000. That gave us a pretty good window. And then when we do that, we're going to get something that looks like this. And if you do point of intersection on your calculator, the point of intersection is going to be 3133.087 and then 10,307.857. Okay, so we get the point, but it said find the number of items, so we only want the X value, and it really wouldn't make sense to make part of an item, and we can't go under, so I'm going to go ahead and round up, so it'll be 3134 items. So there we go on that one. Okay, number 17, let f of x equals 2 different functions depending on what my x is. First of all, let's find f of 6, and since x is equal to 6, that's a number that's bigger than 4, so we're going to use the first equation. So I'll just plug 6 into that first equation, and when I do that, I get 16. All right, and then the next one for part B, f of 2, since 2 is less than 4, we'll use the second equation. So if I put that in there, I will get 5/4 as an answer. And then part C, we're going to have to think about this a little bit. Okay, when you square root a number, no matter what x is, you can only get a positive number. And then if I have a negative in front of it, that's going to turn the number to negative, which means I will always be getting a number that is less than 4, since I'll be getting a negative number. So I'm going to actually put it into this equation right here. And when I do that, I'll put negative the square root of x and then square it. So I'll get 5 over a negative squared is positive, and the square root of x squared is x. So my answer will be 5 over x. Number 18, find the domain of f of x is equal to 5 over x squared minus x minus 72. Okay, although this is in the calculator section, I would strongly advise you to do calculator and non-calculator on this one. Okay, so the first thing we're going to do, I like to draw a graph. And when you draw a graph, you're going to get something that looks like this. And the biggest thing is you might not be able to tell where those asymptotes are, and that's where the non-calculator part of it comes into play, because if you remember, we can't have the denominator equaling 0, so I'm going to find out where that would happen. And so I'm going to factor this. It would be x minus 9, x plus 8, and if I use the 0 product property, that would mean that when x equals 9 and when x equals negative 8, that's not good. So x cannot equal 9 and x cannot equal negative 8. So that's actually where those asymptotes are happening. So if I want to describe the domain, x can be anything from negative infinity until I get to negative 8. It can be from anything from negative 8 to 9, as you can see from this picture. There's a upside down view there. And then it can be anything from 9 to infinity. Notice that I did use parentheses instead of brackets because we cannot include 9 and negative 8 because there are asymptotes there. We can't actually plug those in. So that's the domain. Okay, I'm done.